Singly linked list. Hi, in this video I am going to explain about linked list data structure. This is the special video compared to all other videos available on online. Because we are explained at the point of programming view. Singly linked list is a basic linked list type. Singly linked list is a collection of nodes linked together in a sequential way where each node of singly linked list contains a data field and an address field which contains the reference of the next node. In singly linked list, a node can contain multiple data fields but should contain at least single address field pointing to its connected next node. A node can be represented like this. Here, data field can be represented by yellow color and address field as represented right side. Programmatically, a node can be represented like this. Struct node, int data, struct node star next. Complete node can be represented graphically like this. Here, int data represents data field. And struct node asterisk next represents address field. In a node we can store more than one data fields. For example, in this custom structure extra 3 fields are used. Int data underscore 2, int data underscore 3, char text data 10, and right side is the graphical view of this.
Let's try to understand how to create a linked list. Create a function. To create linked list, let's assume function prototype as below. Void create and insert. Assume main called like this. In main, ask for user to enter number of nodes to be added in the linked list. In a for loop, continuously call the function create and insert till number of nodes entered by user. Define the node structure in global. Declare a global pointer variable as head, which points to null. The scope of this head pointer is till the end of program. This head pointer can graphically represented like this. Let's implement the function. Assume the prototype is like void create and insert. First try to understand how to create a node. Let's assume below is the structure for a node. We can use malloc to dynamically allocate the memory and create a node. For malloc, we are passing the number of bytes to be allocated, that is the size of a single node. Malloc returns the address of memory allocated. So, new node now will points to newly allocated memory. This is the graphical representation. Check malloc is able to allocate requested memory or not. If malloc is failed to allocate requested memory, then malloc will returns null. So, we need to check the requested memory allocated or not. Compare if new node is null or not. If new node is null, it means unable to allocate the memory. Now, complete implementation looks like this. head is the global pointer, which will point to first node in the linked list, and initially it was pointing to null. Create an insert function. Now looks like this. We are creating a new node and checking memory allocated properly or not. Once memory is allocated successfully, we can go for else part. Let's implement else part. Once node is created, we need to fill the data in nodes. So, get the data from user for a new node. After malloc, new node looks like this. Ask the user to enter the data for node, and to get the data, use a local variable data. Once get the data from user, copy that data to new node's data field as new node pointer data equals data. Example: if user entered 40 as value in data field of new node, it will be copy like this. Make the address field of new node to pointing as null. For first time, head indicates to null. Let's continue the program. Initially head will be null, that means empty. So, we need to add checking condition. Add a condition like, if head is equals to null or not. We already created or prepared the new node, and it looks like this. As list as empty, and head as pointing to null. Name new node as head. So, now head points to this node, and this node will be the first node in the linked list. For that, programmatically add the line like head equals new node. So, now it can be represent like this. Let's assume the scenario where head is not null, and linked is already having some nodes in the list. Consider the address of the first node as 0x1000. Size of each node is 8 bytes, if we consider this structure as an example. So, the address of second node is 0x1008. And head pointer next is 0x1008. As we are allocating memory dynamically, these addresses may not be in sequence. We may get random addresses here, just for example mentioned. Similarly, consider addresses for other nodes in the list. Let's assume this is the current status of the list. Let's learn how to add or append previously created new node into the list in this scenario or case. In the else part, add the implementation to traverse in the list and find the node which points to null. The current code implementation looks like this. Now, try to implement the else part. To append a new node to the list, you need to traverse in the list to find the node which points to null. Last node is the one which points to null as its address field. Head is the pointer, which holds the address of the first node in the list. So, take a new temporary pointer, and that should point to first node in the list. For that, just assign head to a new temporary pointer as temp equals head, and this can be graphically represented like this. Check the address field of the current node is null or not. Here, the address field of head is not null. If not null, move the temp pointer to next node. We know temp pointer next is pointing to the next node. So, to move the pointer to that node, just do as below. Temp equals temp pointer next. Once again, check the address it points to is null or not. As address field of second node is not null, move the pointer to next node. Do repeat this step to find a node which points to null. When the list has many nodes, then, to do this traversal, we can add a code like this. Replace if condition with while condition, so that condition will be checked repeatedly till we reach the last node. And once find a node which points to null, come out from while loop. Now, the code looks like this. In the else part, add previously implemented code. Now, try to understand what action needs to take once come out from the loop. When it comes out from while loop, status is like this. In this, third node is the last node. And temp pointer next is null. We have new node prepared previously, like this. Let's assume address of new node created is 0x1018. Add new node to the list by pointing that node as fourth node, that is, last node. For that, programmatically, we can do like this: temp pointer next equals new node. And graphically, it can be represented like this. The address field of temp will be assigned with the address of the new node. Once we come out of loop, it means we got the last node as temp, so assign temp pointer next equals new node. This completes the implementation of create and insert function. Now, complete implementation looks like this. Head is the global pointer which points to the first node in the list. In create and insert function created a new node with malloc and checked memory allocated properly or not. In else part, checked list is empty or not. If list is not empty, took the temp as temporary variable and point to head, that means point to starting node. Traverse the complete list to reach the end node, and once you get the last node, append the new node to the list. Let's implement the function to traverse complete list and display the data. Let's consider prototype as below. Void display list. Assume main called like this. Once list is created, call display list function to display the data from each nodes which is present in the linked list. Head will be the pointer which points to the first node in the list. Consider the situation where the list is empty, and in that case, head itself is null. So, add a condition to check as below. If head equals to null, that means list is empty, and we can print the same message. Let's assume below is the current status of list. List is already has 4 nodes and list is not empty. Here, we can use the same logic which was used before to traverse the complete list. Head is the pointer which holds the address of first node from the list. So, take a new temporary pointer, and that should point to first node. For that, just assign head to the new temporary pointer as below. Temp equals head. If the temp is pointing to a valid node, print the data of that node. To check that, use below code. If temp not equals null, then print the data of that node. Temp pointer data is used to display the data. If not null, move the temp pointer to next node. That means first node is not empty. We know temp pointer next is pointing to the next node. So, to move to the next node, assign temp equals temp pointer next. Before moving, print the data. Temp pointer data indicates data. Now, check the second node is null or not. As the second node is not null, move the pointer to next node. Do repeat this step to find a node which points to null. Let's assume temp points to last node. When the line temp equals temp pointer next executes, it will points to null as below. So, while loop will ends and control will come out of the loop. This indicates we traversed complete list and reached the end node. Now, check complete implementation of display list function. Now, it's the time to execute with Practical. We already created the linked list source file and implemented in C same program implementation, which is used in previous explanation, is used here. Struct node is the structure used to represent the node, and head is the global pointer which points to first node in the list, and scope of head pointer is end of the program. Let's go to main function, asking for the user to enter number of nodes in the list, and for n number of times run the create and insert function. Let's check implementation of create and insert function. Created a node with malloc. Check memory allocates properly or not. If malloc successfully allocated the memory, get the data from user and initialize the data field of the node. Make the address field pointing to null. If list is empty and the head is pointing to null, consider the new node as the first node by assigning the head equals new node. Otherwise, take temp as a temporary pointer variable and point to the head. Traverse the list to get the last node in the list. Once you get the last node, append the new node to the list. Now, check how the display list function is implemented. If the head is pointing to null, that means the list is empty. Otherwise, take a temporary variable which points to the head. Check that is null or not. If not, print the data from that node. Do this till you get the end node, and print null once got the end node. This is just for understanding purpose. Let's compile with GCC as application linked list. Now run the application. For example, enter number of nodes as 5 and enter the data for nodes as 99, 88, 77, 66, and 55. Display list function display the data from each node in linked list, and check the order. We entered the data as 99, 88, 77, 66 and 55. Data is also displayed in the same order. Please subscribe and support us. Like the video and support us to provide or upload more videos similar to this. To subscribe, please click the red button below, and to like, click on thumbs up below. Please provide the comments below about the video, and also comment the details about the video you want, so that we will prepare same content. Thank you.